In this section, I'll be discussing some fundamentals before learning programming language. Get awareness about few things. If you are already aware of this, then you can skip this section and you can go to the next section. Mostly in academics, these are the basics that are taught. So to get awareness about the computers so that we can understand how to use the computers, means how to write the programs, how to utilize them best. So for that, these are the basic topics that I am going to discuss, like how computer works, then what are the number systems like binary number system, octal number system. These are useful in understanding how computer works, right? Then what is a program, why we write the program, how to write the program. These are the things that we will discuss. And about the high level and low level languages, compiler and interpreter, this is very important. These differences are very important, right? Then in the interview point of view also it's important. Mostly student cannot differentiate them properly. So I have given a very detailed comparison of these two. Then what is an operating system? Little bit about operating system. So let us start with the topic. For understanding how computers works, first of all, let us look at a block diagram. This is a very basic thing. Let us study it. See, this is a block diagram of a computer. Let us see the components first of all. See, this is the CPU. It is having two parts, ALU, that is arithmetic and logical unit, and control unit, CU. I'll explain their working. The next is main memory, and this is the hard disk drive which contains the data in the form of files. And this is input device like keyboard, mouse, or stylus, tablet, anything. Then this is the output device like your monitor or printer and speakers. Now let us understand their working. See, the heart of the computer is the CPU, that is central processing unit or microprocessor, or if you present day processor, if you see, that is i3, i5, i7, these processors. Now this processor will have two parts, that is arithmetic and logical unit and control unit. So what is that? Arithmetic and logical unit can perform arithmetical and logical operations, basic operations. So a computer can perform basic operations like arithmetic operations like addition, subtraction, multiplication, or division, or modulus. Then under logical operations, it can compare two numbers. So it can compare less than, greater than, or equal to, and also it can perform logical operations and, or. These are the operations, like it is written in caps, so and or, as well as not. So these are the logical operations basically. So it can perform just these basic operations, right? Then second is CU, control unit. See, there are other things connected like hard disk drive and the main memory, input device and output device for controlling all these things. Controlling means utilizing them. So for that, it is having a separate portion that is called as control unit. So its job is to utilize other resources. This is about processor. Now next thing, let us start from here. This is hard disk. Hard disk will contain files, and those files may be two types, either program files or data files. Like if you take an example, a notepad on your PC is a program file. When you open notepad, it's a program. So there is a file available. Basically, we click on some icon and the program will start. But if you look into my computers and folders, and somewhere you will find a program for notepad, and its name, file name will be notepad.exe. If you search for it, you can find this file. This is a program file. Now inside notepad, if you type something and save, then it will be saving it as a text file. So you may be saving it as my.txt file, right? So this is a program file and this is a data file. This data file is used by notepad or generated by notepad. So finally, hard disk contains two types of files, program files and data files. If you have audio files or music files or video files, all those comes under data files. And if you have a music player or like VLC player or media player, those comes under program file. So we store our program kept inside hard disk, and this is permanent storage. This will be larger in size. The next, If suppose we want to run any program, then that program should be present inside the main memory so that CPU can execute it. So the program is brought from the hard disk to the main memory. It is brought from hard disk to the main memory. So this is a working memory or primary memory or workspace, right? So program should be brought here. Then CPU can execute the program by taking instructions line by line. So whatever the programs we run, they are brought here inside the main memory, right? Then if a program needs some data from keyboard or it has to display something on the monitor, then it can utilize this input devices or output devices. So the program may be taking something from keyboard, or it may be taking something from internet, or it may be reading something from the file. So if program needs some data, it may be getting it from here. Whatever the results generated by the program or interactivity provided by a program, that you can find it on the output device like monitor, or if any output, so it is printed on the printer. And these input and output devices are connected to the system, and they have their own memory. Like I'll show it like this. This is the memory belongs to input device, and this is the memory belongs to the output device. So this I will call it as input buffer. This is a buffer. This is the memory, and similarly that is output buffer. This is output buffer. So if a program has to read something from the keyboard, so it will go to this memory area and get the data from there. And if it has to print something on the monitor, then whatever it has to print, it will put it in its memory area called as buffer, output buffer. It's not that program will directly go and print something on the monitor. It will dump everything inside the frame, that is the frame buffer or output buffer, and that will appear on the screen. Now same way, whatever type from the keyboard, that will go and fall inside the buffer. It directly doesn't enter into the program. It will go and fall into the buffer, and the program can read the contents from the buffer. So this is the communication point for the device and the program running inside the main memory. Now, so that's it. One of the important things we have understood, how they work all together. So once again, I repeat quickly, the programs are here. They have to be brought into the main memory for execution, and CPU will execute them by executing instructions line by line. And if program requires to interact with the user, it uses input and output devices. Now we will learn how that CPU works, how it understands, what does it mean by instruction, how it can understand instruction. So for this, let us start from the basics. See, computer works on a binary number system. What is binary system? Why it works on binary system? See, it's an electronic device. So it works on current or voltages. So voltages are trickily or logically used as binary. How? A low voltage is taken as 0 and high voltage is treated as 1. So it is just like if suppose you have a bulb. This is a bulb, right? This bulb can be off, or a bulb can be either on. If it is on, then we treat it as 1. If it is off, we treat it as 0. That's all. Now, if you have seen electronic circuitry like ICs, I will draw it here. If you look at an electronic circuitry like this is an IC, right? Integrated circuit. This is it is also called as a chip. You can see the photograph also. Now here I have taken the same example. Now this is an integrated circuit. It is having pins here. These are pins. This is electronic, right? Now through these pins we can pass some voltages, right? Some voltage. So in this one particular pin we can pass either low voltage or we can pass high voltage. Low voltage means 0 and high voltage is 1. Now this, it may be taking in and storing it, or it may be sending it out through this other pin, the other end. So how it works and all, we don't have to go in detail, just we have to focus on binary form, right? So this one pin can be either 0 or 1, right? So only two possibilities are there. So that's how this is binary. So we say this is a binary number system, and we call this as 1 bit. We call it as 1 bit. So this is bit. Then if I count 1, 2, 3, 4, 5, 6, 7, 8, 8 bits are there. So this together 8 bits, we call it as 1 byte. So 8 binary bits. Now all these bits are zeros, means with a low voltage. So this is 0, 0, 0, 0, this is 0. Or all those 8 bits are 0, but only the last bit is 1. So this may be like this. Or some are zeros and some are ones, right? So there can be many combinations. Now 8 bits together, these are forming this pattern. They can form various patterns. Now each pattern of bits, we can take it as an instruction. Pattern of bits that is in binary form, we can take it as an instruction. How it is treated as instruction, I'll explain you. I'll remove this and explain you. See, if there is one bulb, then that bulb can be either on or off. Now, if you look at traffic signals and if you consider only one bulb there, usually we'll have 3 different lights. Let us assume there is only one bulb. That bulb is for only 2 things. It can be used only for 2 things. If it is off means you should stop. If it is on means you can go. Or other way, if you say no, if it is on means you should stop, off means you shouldn't, whatever it is, whatever you like, you can set it. So we can set the rule and we can communicate with the people that this will be the code that will be followed now. There will be only one bulb, and if it is on means you can go, if it is off means you should stop. Okay? Like this, we can use this type of codes at many places. Like suppose a officer is there in his office, so bulb is on, he's there. If it is off means he is not there, right? Or if a shop is there, bulb is on means shop is open. If bulb is off means shop is closed. So like this gives a message, this gives a codes. So same thing, electronic circuitry is having voltages 0 or 1 means on and off. Using these voltages, we can make some communication. So one bulb can give you 2 messages, right? Go or stop, shop is open or closed, like that. If you increase the bulbs, so let us take 2 bulbs. If you have 2 bulbs, then what are the combinations possible? With the 2 bulbs, both the bulbs are off, right? Or this bulb is on, or this bulb is on, or both are on. So it means this is giving 4 different messages. 4 different messages. 2 bulbs can give you together 4 different messages. So if you have to communicate 4 things with the people, then you can have 2 bulbs and you can set them on and off, and you should already educate the people and say that this means this means this, so and so. Like example, in an examination, if it's a multiple choice question paper, now students want to copy them, then if one of the person knows the answer, he can communicate to others. For that, they already set the codes. Like if I scratch here, it means option A. If I do it like this, rub my eyes, then it is option B. Like that, they can set the codes. Beforehand, they set the codes and they can understand it in the examination hall. So same thing. Now, similarly, we can use 2 bulbs for giving more messages. So if there are 3 bulbs, then what? If there are 3 bulbs, like just I'm scribbling. So 0, 0, 0. Total, how many possibilities are there? So this is 2 power 3. 8 possibilities are there. Right? So it means, what about 4 bulbs? If you have 4 bulbs, then this is 2 power 4, 16. And what if we have 8 bulbs? So 8 bulbs will be 2 power 8, that is 256. So we can have 256 different commands, 256 different messages. So that's it. So the computer system works on binary number system. These bulbs are nothing but pins, and if suppose there are 8 pins, like this is an IC, so it is just 8 pins. Now each pin, you assume that it's a bulb, and that can be on and off. Total 8 pins can have different commands, like 256 different commands. So messages or commands. So in the same way, this CPU is also built upon messages that are in the form of binary, that is low voltage or high voltage, that is on and off. We'll see more on this one. I'll remove this and discuss further. So now we can say that the language of computers is binary. They understand binary language, that is in the form of zeros and ones, that is low voltage or high voltage. So all the instructions and the data, everything should be in the form of binary. So the language of the CPU is binary. So how it performs arithmetic and logical operation? It performs operation on binary number system, right? So now I can say that the language of machine or the computer is binary. But we understand decimal number system. We are not comfortable with binary number system. We prefer working in the decimal number system. So in comparison with the decimal number system, how it is equal to binary form, let us look at it a little bit. See, in decimal number system, we have the digits from 0, 1, 2, 3, so on to 9. We use these digits to form a number. Then in binary number system, there are only two numbers, that is zeros and ones. So anything we want to understand in the form of decimal. So in decimal form, if it is 0, then it is binary also 0. If it is 1, then it is also 1. Then in decimal, it is 2. When binary, it is 1, 0. And 3 is 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1, and so on. So this is the binary form of these decimal numbers. Now, based on decimal number system, we understand that this CPU, or the arithmetic and logical unit, perform operations. So it knows the instructions, it knows commands, like 0 means add. Suppose, like, assume that 0 means add two numbers, 1 means subtract two numbers, 2 means multiply them. Like this, they are forming instructions. So there are some predefined instructions that are there inside that circuitry, electronic circuitry, and that is logically designed to work commands. So the commands that we already know, we have seen that it can perform arithmetic and logical operations. Those operations are given in the form of codes, and it already knows that which command means what I have to do, and we write the programs in the form of binary. So the programs must be present inside the main memory in the form of binary. So each line of program, that is an instruction, CPU will take an instruction and execute it, because it already knows what it has to do for which code. So like these becomes the codes as instructions for performing specific instruction. So if you study some machine language or low level language of computer system, you can understand that its instructions are in the form of binary, right? So that's all. We end here. The conclusion of this talk is how computer works. Computer works on binary number system, right? And why they work on binary system? Because they are based on electronic, and in electronic, signals are either 0 or 1, that is low or high. So that's how everything is built upon binary. But we don't understand binary number system. So to know how it is related to decimal number system, we should understand some number systems. In the next video, we will discuss about number systems. So in the previous video, we have learned how computer works. There I have told you that computer works on binary number system, that is zeros and ones, or on and off. But we understand decimal number system. And also I told you that the codes, that is numbers, can be used as codes for giving an instruction or a data or a message. See, I am just going to give the introduction to the number system. But there is a topic, the details are there, conversion from octal to binary, and so many conversions are there. If you want to learn that is mostly required in academics. If you want to learn that, there is a section called miscellaneous. You have to go to that section and study in detail about the conversion. So the videos are available there. Here in this video, I don't want to waste your time. I don't want to go in detail right now. So I'll give you introduction to number system. So let us look at. See, basically we use decimal number system. In decimal number system, the pictures or figures or symbols are from 0 to 9. Total 10 symbols we have, 10 symbols. Then computer works on zeros and ones. So how many symbols? Only 2 symbols. So binary number system have only 2 symbols, 0 and 1, that's all. See, one thing I'll tell you. Once we have finished with the last symbol, after 9 we use the combination of symbols. We write 10, after that we write 10. 10 means 0 and 1, we are combining 1, 0. So this place is 1, the next place again will start from 0, 1, 2, 3. So we have finished with the symbol, so that's why we are taking combination of symbol. So same way, we have only 0 and 1, then what is the next number? It is 1, 0, we have to take the combination. So don't read it as 10, read it as 1, 0 in binary form. That's it. So I have some numbers here, just look at them. 0 in binary form is 0, 1 is 1, 2 is 1, 0, 3 is 1, 1, 4 is 1, 0, 0, 5 is 1, 0, 1, so on. Up to 16 I have written. Now if you want to be strong in the concepts of programming, you want to study it in detail, very minor things, you should know these numbers. So some of them you should remember, some of them you should be quickly able to convert them. So that I have explained in miscellaneous videos, there you can learn it. Next, what is this? Octal and hexa. See, remembering a number in 00111 is too tough. It's too tough. We need a simple method. So what people have done to make this simple, octal is introduced. So you can take 3 digits of a binary number and convert into octal. Then even this is also less. So they have introduced hexadecimal. Hexa means 6 plus 10. Hexadecimal. Total 16. So 0 to 9. Then after that, for 10, English alphabet A is used. Then B, C, D, E, F last. So there are total 16 digits in this one. Figures in this one. Symbols in this one. Then after that, we take combination 1, 0. So how to convert this into this one or this to octal, binary to hexa, everything is there, you can study it. But in this video, I'll just show you conversion from decimal to binary, then binary back to decimal, just to give you the idea. So let us take an example. I have a number, decimal number, base 10 means it is decimal number. So this is base 10, this is base 8, this is base 2, and this is base 16. So we write 10 here. Because 25 can be there in octal also, hexa also. Which one it is? Now, to show that, we will say decimal as 10. Then, how to convert into binary? So, the method is, we find out, successively we divide it by 2 to get the binary form. 2 ones 2, 2 twos. So, 2 12s, 24, remainder is 1. 2 6 12, remainder is 0. And 2 3s 6, remainder is 0. 2 ones 2, remainder is 1. So we take remainder here, we don't write decimal. 2 0 times is 0, remainder is 1. So take the digits from bottom towards up. So the digits are 11001, 11001. This is the binary form. So this is how a decimal number is converted into binary. Then binary back to decimal, let us see the procedure. If I take the same number and convert into binary decimal form, so take the number in the boxes 1, 2, 3, 4, 5. So I need 5 boxes. Then write this number 11001. Then at this bottom, write powers of 2 from right side. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Now 1 into 2 power 4 plus 1 into 2 power 3 plus 0 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. This is how much? 16 plus this is how much? 8 plus this is how much? 0 multiplied by anything is 0 only. 0 multiplied by anything is 0. This is 1. So how much this is? 24 plus 1. So this is 25. So we got this in 25, that is number system, decimal number system. So this is how the conversion is done. So that's it. This is sufficient. I have shown you decimal number in binary and binary back to decimal. So like this procedures are used for converting them using pen and paper. Now electronic circuitry internally handle these things, right? For humans, we follow these conversion methods to understand how it is represented in binary form. So knowing about the number system will definitely help you, right? Give you detailed understanding, but associated with some other subjects are also there. So in other subjects, it will be very helpful, right? That's all about number system. See, the coming videos are based on the concept only, right? So you have to be calm and follow each and every video if you are a beginner. All right. So don't skip any video, right? I am not going to directly start showing you how to write down the program and all. First, you should have some basics. If you're learning programming for the first time, study all these, watch all these video, and you will be prepared for understanding programming. All right. So watch the next video. In this video, I am going to discuss what does it mean by a program, why we write program, and how it is possible to write a program. So we'll learn about these basic things. See, in the previous videos, already we have discussed that our computers can understand binary form of language. So there are some predefined set of instructions that a processor or a CPU can understand, and we have to use those instructions for performing a task. Now, what does it mean by task here? So let us understand why we need computers. What is the purpose of using computers? We use computers for performing computational tasks. So what is this computational task? All those tasks which are done using pen and paper, the computations. By using formulas, by using any expression, we put the values and get the answer. We use various formulas or various steps. So computation work, that is paper work. So for that purpose we use computers, right? So that computation work can also be done using calculator. Yes, it can be done using calculator. So let us understand first how we use a calculator, and then I'll show you how we can use computers and what does it mean by programming. We use calculator like this. See, for example, if I have two numbers and I want to add them, first number is 13 and second number is 27, and I want to add them. So take a calculator, hit first number 13 and then press plus, then hit second number 27, then press equal to sign. So I'll be pressing plus sign and equal to sign, and finally I get the answer, that is 40. So I can use a calculator for adding two numbers, a simple task. So I don't need a computer for this one. Then next, if I have a list of numbers and I want to calculate average of those numbers, so I'll just write down few numbers here: 10, 15, 8, 6, 9, 5, 12, 13. So 1, 2, 3, 4, 5, 6, 7, 8. I will add few more numbers, 11 and 16. So I have total 10 numbers and I want to find average of these numbers. Then how to use a calculator? Now watch it. I have to enter or hit 10 for the first number, then plus the next number, then plus the next number, plus next number. I have to go on adding them, and that sum will be getting accumulated. So finally, I'll get the total of all these numbers. Like total is 105 for these numbers. Then I should also have the count of numbers. Total how many numbers I have? 10 numbers I have. Then that total I should divide it by 10. Then I get the result, that is 10.5. Here calculator doesn't know how to find the average. I should know how to find the average. So for finding an average, I should have the list of numbers and I should go on adding them, and then I should divide them by number of numbers, that is 10. Then I get a result, right? This is not a simple operation. This was a simple operation. This is having a procedure. Yes, there is a procedure for finding average. Now similarly, there is a procedure for finding the maximum number or the total number of numbers. There is a procedure for searching a particular number in this list. So for various things there are some procedures. And if you have learned about statistics, then I want to find a mean of these numbers or median of these numbers. So there is a procedure for this. If you want to sort these numbers, then there is a procedure. So calculator doesn't know the procedure, means the steps involved for completing a particular task. Now, how we know it? Our teachers has taught us that procedure. So we know the procedure, right? So same procedure, can we teach it to calculator itself, so that just we will tell we want average. It should ask what are the numbers. These are the numbers, and it should give us the result without asking us how to do it. We want our calculator to be trained on this one. So it means we want a programmable calculator. Yes, that's it. So the extension of calculator, I can say, or the next level to a calculator is nothing but computer. Computer is a programmable computational device. We can define a procedure by giving all the steps one by one to our computer system, and we call it as a program, and the program computer system or a CPU processor will execute those set of instructions and give us the result. So that's what is programming. That's it. This is what we use computers. And what is programming, I have told you. Now more about program, more detail and clear picture about a program I will give you. Now I have taken a list of numbers. So this is a list of numbers. Let us say the procedure is same. I want to find average. So what are these numbers? These numbers are nothing but data. This is data. Then for performing average, there is a procedure, right? So that procedure, the steps involved in that one. So those are nothing but instructions. So we can say these are instructions, right? So there are two things now, data and the instructions upon that data. So a program is nothing but collection of data and the set of operations or instructions on that data. So we have to focus on only two things in our programs. What is the data you have and what you want to do with that data. So what are the steps? What is the procedure? See, without data, there is no need of instructions, right? Instructions are useless. And if you have just data, no instruction, then you don't know the results, right? So these are the two important parts of a program. So we have to focus on this one. We have to learn how to represent our data, and also we have to learn how to write on the instructions that will execute or compute the data to get the result. So this is what learning programming. Now, one important thing, for learning programming, you should already know the procedure, right? This is the very important point. Here the most of the students get confused. They think that learning programming will make them learn procedure. No, learning procedure is different and writing programs is different. So we are going to learn two things, how to write a program and how to write our procedure, right? How to convert our procedure into a program. So a program contains data and the set of instructions. Now let us come to the computer side. See, this is our machine, computer machine, right? So let us say this is CPU. Now this is myself. Now language of CPU is zeros and ones, binary. How to represent data in that one? Data in that one in the form of zeros and ones. How to represent instructions? That is also in the form of zeros and ones. Both data as well as instructions are in the form of zeros and ones, that is binary. Then what is my language? My language is English language. So instructions are in English and the data is also English. Like if you ask me to read these numbers, I will say 10, 15, 9, 6, 8. This is English. Numbers are also in English. If you know any other language, then these numbers are called with different words are there, different names are there for them, and the figures are also different, right? So this is English. This is English. So my data is also English and the instructions are also English. And CPU's language is machine language is zeros and ones. This is binary. This is machine language and this is natural language, that is human beings language. Now we want our machine to learn our procedures. So we have to learn either machine language or we should develop our machine so that they understand natural language. Any one of this, right? Now either way it's not possible. Either way it's not possible. We can't learn machine language and computers are not so much developed that they understand natural language. Now recent computers, they are having some artificial intelligence that are useful for pulling the data but not for programming it. So for programming it, machine should understand natural language. So this is not yet happening, right? Then what we need now? We need some intermediate language so that's easy for me also, easy for machine also. So that's what here comes programming languages. The programming languages that we use like C, C++, Java, C#, VB, Python, all these languages, they come under programming languages. So we learn this language and whatever our procedures are, we transform them in this form, and these languages will help us to transform that procedure into machine language. So from natural language to programming language, then programming language to machine language, translation is done. So this translation is not there, we learn it, we have to learn it, right? If that translation is available, then anybody can do programming. Just you say, it will become a program. So this we have to learn a programming language and write our procedures in that language. Then from this language, there is something called compiler or interpreter, right? I'll just write in short. We are going to learn that in this next video. Compiler or interpreter will translate that into machine language. So this is how programming languages are useful for writing programs. So we should learn some programming language. So that's all about what does it mean by program and why we need programming. Let us revise the things very quickly. So I started with a calculator. Calculator is not a programmable device. Now we want our machines to know the procedure. Just we will give the data, we will not know the procedure. So for that we need a language so that we can write a program. So what a program will contain? Data and the set of instructions upon that data. These are the two main part or ingredients of a program. But this has to be written in machine language. We don't know machine language. So we introduce some intermediate language, that is a programming language that is helpful for us and which will translate that into machine language, machine code, and the program that is understandable by CPU. So that's all in this video. In the next video, I'll explain you what does it mean by compiler and what does it mean by interpreter, what are the differences. By taking few examples, I'll explain them that I have already used their name here. That's all. So in the previous video, I have already explained you that we talk or we understand natural language, human beings, and machines have their machine language, and that language is in binary, that is zeros and ones, right? So it is in the form of zeros and ones. So we say this is binary language. Binary language, we can call it as machine language. Machine language. So that is termed as low level language. Low level language. Machine language is low level. Low level means actual machines language. We can't understand it. So when the machines were introduced initially, it was very difficult for people to write the program. So it was not common. Machines were used in laboratories. It was not used by masses, or it was not available at consumer level. So at that time, so the people who developed, they used to learn something from this machine code, and they used to write everything in machine code form. That was very tough, and it was very initial stage. Then later they thought that there should be some method to make it easy. So they introduced some language called assembly language, right? So this assembly language was little easier than binary, right? So this nobody can think of working on it except the one who has manufactured the machine. Now assembly language was little easy. It can be taught and it can be learned and it can be practiced and used for writing the program. So this was used for some time, right? And this became a base for conversion from this language to machine language. So still that is also low level language. It's very difficult for learning. If suppose a class of 100 student, and if somebody is teaching assembly language, then there is a chances of learning one student learning it, right? So the learning curve is very high and it's very difficult, right? As a part of academic, students learn it for some time and they finish the exam and forget it. So anyway, we don't have to use it. And if at all you want to work in systems programming, that you want to write operating system level programs and all, then you need to learn about it, right? So I'll give you the idea about that one, where this assembly language is useful if at all you need it. Then this is also low level. So under low level, we have two languages under low level, that is machine language and assembly language. Machine language and assembly language. In short, I am writing them. Then, as this was also difficult, we wanted some English-like language. So, English-like languages are high-level languages. They are not exactly like English, and they are not more like machine code, right? So, they are in between. So, that is easy enough for anybody to learn. So, that are high-level languages. So, there are n number of high level languages. Lots of high level languages are there. Like present day we are using languages like, I'll name them. So these are easy to learn, right? High level languages: C, C++, Java, Python, C#, Visual Basic, Visual C++, and the list goes on. There are various languages, right? So these languages, we call them as programming languages because we can program them. We humans can program them. Actually, this assembly language is also programming language, but that is low level programming language, and these are high level language. So we are much familiar with these languages. So these are very easy to learn. Now, no doubt for a beginner, it is a little tough in the beginning. But when you are used to, then when you learn any one of the language, it's sufficient. You can learn all other languages. You should learn one language thoroughly, then you can understand all other languages. They are on the same patterns. Now, and one more thing about this. These languages, we can categorize them as compiler based languages, and some are interpreter based languages, and some are hybrid languages. What are these? We will learn this in next video. In the previous video, we have discussed about low level languages and high level languages. Now we already know that high level languages are more like English, that are easy for humans to understand. So in the last video, I have explained that there are many programming languages that are high level languages, and some languages are compiler based and some are interpreter based, and some are hybrid also. So what does it mean by compiler based? What does it mean by interpreter based? We will understand this in this video. So the topic is compiler versus interpreter. Then also I will discuss about hybrid languages. So for understanding this, we should know what is the job of compiler and interpreter. What are the major tasks? Let us see. See, the task of this compiler or interpreter, whatever it may be, first thing is it will check for errors. Check errors, right? So this is the first thing. Then the second thing is convert into machine code. Convert into machine code. Right? So I will write MC as machine code or machine code language. See, high level language, it gets converted into low level language, that is machine code, which is understandable by machine. So compiler and interpreter, they do this job of conversion, right? And the third thing here involved is execution of a program, that is running the program. Running the program means, you know well that I already told you that the programs are brought into the main memory and they are executed by the CPU. So the machine instruction will come inside the main memory and CPU will execute it. That is execution, running of a program. Now, for these three things, let us understand this. See, when we write any program, like this is a program. So I will call this program as a source code. When you write any source code, then that source code may be having errors. So why you will have errors? See, you may be mistyping something, or you might have forgot some statements, or you have not written the statements properly. There could be some errors. Those errors are called as syntax errors. So whether it is compiler or interpreter, it has to first check that the code, that source code you have written is not having any errors. This is the first thing. And if there are no errors, then it will convert it into machine code. So majorly there are two tasks of compiler or interpreter. They both do this thing. Check for the errors. If the source code is error free, then generate machine code, right? Then third thing, execution of a program. If I talk about execution, compiler doesn't take the responsibility of execution, but interpreter takes the responsibility of execution. Compiler is not involved in execution of a program. Interpreter is involved. So these things all we will learn in detail, right? So step by step we'll learn everything about these differences between compiler and interpreter. So just keep in mind, these are the three major issues that are related to compiler and interpreter. Now let us compare them one by one. For comparison, already I have taken some program code here. This is the source code written in C++, and this is the source code written in JavaScript. So I have taken these two examples. C++ is a compiler based language. It is having a compiler, it's not having an interpreter. JavaScript, which is useful for writing web pages, it will be a part of web page and it runs inside browser. Mostly the websites, if you visit from your browser, if you check the code, you will find HTML and JavaScript there. So it's a common name, everybody knows about it. So this is used in web programming. This is interpreter based. So this is the source code I have written. This is not the machine code. So this can be understood by a compiler and human beings. This can be understood by interpreter and human beings. So I have taken an example of compiler based language and interpreter based language. Now let us understand the differences. See, if I have this program and I want to compile, means translate into machine code, then if I give it to a compiler, compiler will convert this code into machine code. And as you can see that I have written this program into two pieces, right? Two pieces are there. So like this is the add function, this is the main function. No doubt we don't know anything about functions right now, but I have just written the program into two pieces. So when the machine code is generated, it will generate two different pieces, that is machine code for add function and the machine code for main function. So only the thing that you have to understand here is that if you break the program into pieces, then the pieces will be generated in machine code also. That is important. Now, this is the machine code generated. See, this is the file first.cpp. So after compilation, we get some file, some intermediate files also, and finally we get a executable file and we get first.exe file, executable file. So here on the hard disk I have shown here first.cpp, and if you call a compiler, compiler will run in the memory and it will take this program file and understand and check that there are no errors. First thing, if there are no errors, then it will generate a machine code file, that is first.exe, and it will save it on the hard disk, right? So you will get a separate file called first.exe. This is first.exe. Compiler generates machine code. That's all. If there are no errors, it has generated the machine code. Job of compiler is over. Now, next step, I want to run. As I said, there are three things, right? Checking for errors, converting. No errors, converted. Now execution. If you want to run the program, now you can run this program, first.exe file you can run. And you can run it as many times as you want. You don't need a compiler now. Compiler has translated once, that's enough, over. Now you run your program n number of times. Whenever you are running your program, this exe file will be used. Source code is of no use now. And if at all you are making any changes in this one, then you can recompile, you get a regenerated first.exe file, and that will be a new program or a fresh or updated program. So it means compilation or translation of source code to machine code is done only once. This is the first point. And compiler generates a separate executable file. This is the second point. Then the third point is whenever you want to run the program, you don't need a compiler. Translation is done only once, because that's the reason you don't need any compiler when running the program. And one more important thing of a compiler is that, see, there are few lines, 1, 2, 3, 4, 5, 6, 7, 8, some 10, 15 lines are there, let us say. In these lines, if there is any error at some place, suppose if I start from here, 1, 2, 3, 4, 5, 4 lines are perfect and the fifth line is having any error, your program will not get compiled. Your program will not get compiled if there is any error. Though it is in fifth line, first 4 lines are correct, right? But it has to generate a complete machine code. It cannot convert into machine code. So these are the points about compiler. Let me repeat quickly. Compiler will generate a machine code file, separate file, and translation of a program is done only once. Compiler will not be there when the program is running, right? Mostly students believe that compiler will be there at the time of execution. Compiler will not be there. And last point is that if there is any error in some line, then the program will not get compiled. Now, coming to interpreter. So for explaining about interpreter, I'll just remove this and I will change these files. Now let us look at the interpreter. So for interpreter, I have some JavaScript code. Don't try to read and understand the code. Just some lines are there, okay? These are written in JavaScript. Now, how interpreter works? Let us see. See, this is suppose a file called my.javascript, that is my.js, and that file is present here. Then I also have a program called Chrome, that is browser, a commonly used browser. So I am using a name Chrome here. So this chrome.exe, this is a browser. JavaScript runs inside browser. It cannot run independently. Now, how this JavaScript works, how Chrome works as an interpreter for JavaScript. Let us see. See, first of all, for running this one, for execution of this one, so I am not saying translation or anything. Directly I am saying execution, third step. Remember this. I have to run Chrome, and inside Chrome, I can run that JavaScript. So I can open that file in Chrome. Usually we don't open the file from local machine. We get the pages from internet. But here, if you open Chrome, then you can open that JavaScript file. If it opens inside Chrome, then Chrome will be executing this code, right? Whatever it is, just leave it what it is doing. So this code can be executed by Chrome. So how? So Chrome work as an interpreter for JavaScript. So now you can see how it works. First of all, Chrome will run. Then if you make it read this file, it will take the file. Then it will go through this file and it will translate it line by line. And after translation, it will convert into machine code. Yes. And also it will get executed. Chrome will execute it. Like C++ program, compiler will not execute it. Here Chrome is an interpreter for JavaScript. Chrome will execute it. Yes. So how it will execute? It will not translate whole thing, then start executing. It will translate first line, execute, second line, execute, third line, execute. So line by line translation as well as execution. Now let us compare this compiler and interpreter. See, compiler will read the program. It will be generating machine code line by line only, but it will generate the machine code for separate entire program and make a separate file. But a browser, which is an interpreter for JavaScript, it will not create an exe file for JavaScript. So this is the first difference. Second difference, compiler just translate, it will not execute. But interpreter, that is Chrome, it will translate as well as execute. This is the second difference. Second difference. Third difference, if once translated into machine code, now you run it as many times as you want, you don't need compiler. Translation is done only once. But here, whenever you want to run JavaScript, you should call Chrome. Chrome will run it. Every time it will translate. So if n times you are executing, n times translation will be done. Interpreted language. Then here if there is any error, then it will not compile. Here if there is any error here, suppose in some line, then first two line definitely will execute. Interpreter will not stop because it is converting and executing, converting, executing. If there is any error at any point, then it will stop. So till there it will execute. Interpreter will execute. Compiled program runs independently. Interpreted program runs inside interpreter. Now finally, concluding point. Who is faster? Compiled programs or interpreted program? Compiled programs are faster because they run independent as a separate program. Interpreted programs are not faster because they don't run independently, they run inside interpreter, context of interpreter. So they are slower, which are easy to write. If there is any error in a single line, it will not compile, you cannot run. If there is any error in some line, then a line till before that line you can execute. So it's easy. So up to some extent you can see the program running, and at this place, okay, there's an error, I can remove it. So these languages are very easy. Interpreted languages are easier than compiler based language, right? So this is the difference between compiler and interpreter. Now I'll give you one small example. With this you can remember this entire thing what I have discussed. Suppose you are making a Chinese recipe or dish, you are preparing a dish. So you have a recipe of a Chinese dish. It is written in Chinese. It is written in Chinese. You don't know Chinese. I know Chinese and English. So I can help you. I can translate it. Right? So you want to prepare a dish. Now, what are the methods I can translate? First method, I can read that entire recipe and prepare an English version and give it to you. That's the first method. Then second method, I will take that Chinese recipe, read first line, translate it, and I will tell you, right? And you will also execute it. Means you are right now preparing a dish. I will say, take a vessel of this much size. Okay, you take it. Then take this ingredients. You take it. Boil, take some water and boil. You will boil it. So I am reading in Chinese, translating in English, and I am also getting it executed. You are doing it. This is the second method. Now let us compare them. First method, if I give you an English copy, then translation is done only once. And you don't need me when you are preparing a dish. Two differences. Right? And you can work independently, right? Same thing, second difference. Now here, every time you want to prepare a dish, again you will come, oh Chinese, please translate. I will translate, right? This one. And second thing, whenever you are preparing a dish, I must be there with you. You are not independent. That's it. That's how you can remember the differences. So if I translate and give you a separate English version on a separate paper, now that Chinese version you can keep it in shelf. You don't need it. You have the English version and you don't need me on that same recipe once again. But here you need me every time because I am translating and I am getting it done by you, and that's all. Work is over. So same way, this Chrome will come inside the main memory and it will take JavaScript and translate and get it executed by CPU. So this Chrome is myself and this is Chinese recipe and this is yourself who are executing. You understand machine code, right? In case of compiler, you called me, I took first.cpp and convert it into first.exe. Now you don't need me. Whenever you want, you can execute directly that exe code. So these are the differences. Now, finally, let us talk a little bit about hybrid languages. Hybrid languages like Java or all .NET languages like C#. Now these are hybrid. They have a partial compilation, that is first compiler will convert into bytecode, then later this is converted by JVM into machine code. So I'm not going to explain in detail, just briefly I'm telling you. They have two steps. Compiler is also there, interpreter is also there. JVM acts as an interpreter, right? This is an interpreter. Why two stages? Compiler will check what? Compiler will do what? It's not generating machine code. The compiler just check for the errors. If there are no errors, bytecode. Bytecode is error-free code. Then JVM will convert or translate into machine code. So two-step process. As I highlighted three things, right? Checking for the errors, translation, then machine code and execution, right? Third was execution. So compiler just check for the errors. Error-free, it's not machine code, it's bytecode. Then JVM will translate into machine code and also execute. So it's an interpreter. So interpreter for bytecode, not for source code. So these two steps are there for providing platform independency, or in .NET languages it is for language independency. These are the different topics. Anyway, just we got the idea that there are some compiler based languages, there are some interpreter based languages, and some are hybrid which have compiler as well as interpreter that take the benefit of both and try to provide some excellent features. So that's all about this topic. Let us continue with another topic in the next video. In this video, I'll give you a brief introduction to operating systems. There are well-known operating systems, commonly people use them, right, on their laptops or on PCs. The known operating systems are Windows, this is a very famous operating system, and Linux. This is mostly used by professionals, or this is used in companies. Third, that is Mac OS X is operating system. These are the commonly found operating systems. So what actually an operating system is? See, operating system is a master program. It will utilize all the resources of your computer system and provides services to the user. See, these are the components in a computer system. Like already we have seen this CPU and the main memory, then the input and output devices. So I am showing keyboard, mouse, monitor, printer and network, and majorly hard disk. Right? Now, the programs running here inside the main memory may require these peripherals or the resources of your computer system. Or let us draw a user also here. User is using computer system and he may be using these resources like accessing internet or accessing some files and all. So program user will not directly use it. He will use them through a program only, definitely. So finally, user should be benefited from the resources and the program. So this is the responsibility taken by an operating system, and it makes the environment, it provides an environment easy for a user to use the computer system. So even on your mobile phone, you have operating systems like Android operating system and iOS operating system, right? So on mobile phone also, it's the same thing. Like you have a storage and a RAM, that is main memory, and the processor is there. Display itself is, that is screen itself is display, and its screen itself works as an input or a touch device, touch screen. So both are similar. Now let us know how operating system works. Listen, when you start your machine, computer, PC or mobile phone or laptop, the first thing that you see is it is getting ready. And if you're using Windows PC, you will find a Windows logo and you will get a message, it's starting, Windows is starting. And on your mobile phone, Android mobile phone, you will get a message at the bottom that is Android, it's getting ready. So the very first thing when you start your machine or a device, it will get ready upon operating system. See, operating system actually is present in your storage or a hard disk. So I am showing it as Windows EXE. Like Windows is also a program, operating system is also a program, but it gets loaded by itself. So it will start by itself. The moment you start your machine, operating system will get loaded and operating system will start executing. So your hardware or your device get ready upon operating system. So this should come inside main memory. So I will write just OS in short for operating system. Operating system will get ready first inside the main memory and the CPU will start executing that operating system. So the very first thing that you get a screen with full of icons and the cursor for mouse, everything, all this is displayed by operating system, and the operating system is ready to take the instruction from you or the commands from you. So you click on some icon for opening an application. So how it works, operating system running here inside the CPU will bring that program inside the main memory and it will ask the CPU to execute that program. So that program runs within the context of operating system. Now it is not independent, it's running as a part of operating system within the control of operating system. It is perfectly monitored by operating system. So operating system will get our programs execute. When you touch any icon on the screen or when you double click any icon on the screen on your PC, program will get into the main memory and the operating system will start executing it. Now the last thing, when a program is accessing a monitor or printer or network, anything, program cannot directly access anything, cannot directly access. It has to get the work done or make a request to the operating system. It has to display something on the monitor, it should ask the operating system that I want to display this. If something is typed from the keyboard that is coming in and if program wants that, then it should ask the operating system to get that input. So programs cannot access the hardware directly. How to handle them, how to access them, like multiple programs may be running, right? So one program cannot capture the device. So operating system take care of all these things. So it will manage the resources. So everything has to be done via operating system by making a request to operating system. So when any program, when it is making a request to the operating system for accessing the resources or getting services from the operating system, then it does that by using system calls. We say that these are system calls, or we also call it as API, but system call is the right term for this one. Application program interface or system call. A program will make system calls to the operating system for availing services. So that's all. I have explained you how operating system will start on the machine and how it will help our program execute. Now in short, operating system is a master program which will take all the resources under control and provide services. Like you may be knowing a sports department or library in your college, like librarian will hold all the books, right? He has a control over all of them. He has the authority to issue the book or claim the book back from a student. So he decides who should get how many books and all, for how much period a book should be given to issue to a student. Everything he decides, right? So whether a book is available or not available, he knows everything. So a student cannot directly go and pick up a book and take it home. He has to request to the librarian, and when he is returning again, he is give it back to a librarian. So librarian manages library, that is resources. Same way, operating system manages all the resources of your computer system, and the programs will use these resources with the help of operating system. That's all, little bit about operating system. So now you should know that there is something called operating system also between CPU and the other resources and your program, right? So there are few things that are done by the operating system during runtime of your program. So you should be aware of this one. So this is sufficient for knowing about operating systems. So that's all in this section. In the next section, we will cover a few more concepts that are very useful for programming.